We're going to spend 2 days looking at something called composition of functions. We'll start with a warm-up. What is the equation of the following function? So with this one, you should be able to recognize its absolute value, and you want to start at the vertex. So the vertex right here, and that vertex is -3, and then it's up 2. Okay, so this will be our h and our k. So we know its absolute value. Here's the parent function. And we know that it is shifted left 3, up 2, but also flipped over the x-axis, and the slope is not 1 here. The slope is negative 1/2. So our slope is negative, not 1/2, sorry. So slope is negative, it looks like down 2 over 1. So -2. And it makes it skinnier. All right, so let's put that all together in this equation. Y equals, the slope is -2, so we'll stick that right on the outside. It goes 3 to the left, and remember that's +3. It's the opposite of h. And then the k value is up 2, so +2. Here's the equation of that absolute value function, and you can plug that into your calculator to verify. Here's our problem for the day. Maybe I'll just start over. Kohl's has selected your class to help determine which process would be better for the store. A customer can turn in 2 different discount cards per purchase. So this is for the store. The discounts are 30% off the total and a $10 Kohl's cash cash certificate. Would it be better for the store to take 30% off first and then deduct the 10, or deduct the 10 and then reduce by 30%? So I'm going to give you guys some time in class to try to figure that out. Show work that verifies your decision. Okay, let's do it with notation, composition of function notation. We'll do the notation, then we'll define composition of function, which is looking at 2 functions. Okay, let's call the $10 off f of x and the 30% off g of x. Write the function that represents each of these situations. All right, so f of x. Oops, it keeps restarting. I apologize. All right, so f of x is $10 off. So it's whatever total is, x minus 10. G of x is the 30% off, and if you're taking 30% off something, oh, I'm going to write them up here. I'm sorry. This right here is the composition part. Okay, so I should have written it right here. So again, f of x equals x minus 10. G of x is the 30% off. If something is 30% off, you're still paying 70%. So if you're paying 70% of something, remember multiply, so 0.7 is, 70% is 0.7 times x. So again, if it's 30% off, you're paying 70% of the total. All right, let's write a composition of functions that represents the $10 off first, then the 30% off. Okay, so, and again, the notation is going to look like this. So 30% off is second. So first we do f of x first, and then after we do $10 off, we do 30% off of that. So we're going to do g of this answer. Okay, so mathematically, what does that look like? Again, we have the x minus 10 first, and then we're going to plug that in, and whatever that answer is, we'll take 70% of that answer. Here's what it looks like. 0.70 times x minus 10. All right, so here's the expression we're looking for. It's called g of f of x. We do f of x first, and then we plug it in for x for g. So 0.70 times x minus 10. Okay, so again, we did x minus 10 first. I put that in parentheses and took 70% of that. All right, let's do it the opposite way. Let's write a composition that represents 30% off first, so the 0.70x. Then you take $10 off of that. So we're going to take $10 off of that. So we're plugging this into this x right here. And then taking the $10 off. And the notation for that, we start with g of x. And then we do the f of that. Excuse me. Here, grab a drink. All right. So again, the first situation, we do x minus 10 first, and then take 70% of that. And in the second one, excuse me, we take 70% of the price first, 30% off, and then subtract 10 after that. So here are the 2 functions. Let's rewrite them a little bit neater. Okay. So I'm going to rewrite them a little bit neater, then we'll solve. So again,
if your last name begins with the letters
30% off.
M
Okay.
through N, then you need retakes or you have not had your pictures taken, please go to the small gym at this time. M and N.
So again, here is the first composition of functions. So $10 off first, and then 30% off of that, so 0.7 times that. And now if we distribute that, let's see what this simplifies to. So it would be 0.7x, or 0.70x, or 0.7x, minus, and 0.7 times 10 is 7. Okay, so there's that first function if we simplify it. The second one is 30% off first, so 0.70x, and then $10 off. Okay, so we're plugging that in for x here. And if you look at the two, which one is going to be cheaper? Well, for the customer, this one is better. Because in both of them you have 70% off, but now we're going to take $10 off of that. And in this one, you take 70% off, and then you only take $7 off of that. So this is better for Kohl's. So order does matter when you have a percent off, but then an amount off. So you would, if you're the customer, you would want 30% off first and then $10 off of that. If we're taking $10 off first and then 30% off, you've reduced the price, and so you're taking 30% off of less. And that's why Kohl's would want to use this one if they wanted to make more money. All right, so let's define composition of functions. Okay, so the term composition of functions or composite functions refers to the combining of functions in a manner where the output from one function becomes the input for the next function. So we're looking at two functions, using the answer for one to find the answer for the next one. So this is how I think about it. Use your answer from the inside function to get the answer for the outside function. And I wrote this notation without defining it, but f of g of x, we did the inside one first and then the outside, and it's read like this, f of g of x. So where you see the parentheses, that's of f of g of x. All right, so we're going to look at composition of functions in several ways. The first is using a table. So remember, it's using the answer from the inside function to find the answer for the outside function. So let's take a look at this one. Here's the inside function. Start there first. The answer to g of negative 2, this is x. So if the x value is negative 2, what's the y value, g of x? All right, so here's the g function. If x is negative 2, the answer is 1. So let's replace this. This answer is 1, so now we're looking at f of 1. All right, so f of 1 means when x is 1, what's the answer, f of x? So when x is 1, the answer is 2. So we say f of g of negative 2 equals 2. So you did the first function, use that answer to find the answer to the second function. The answer is 2. Let's try another one. Start with the inside function, g of 2. So when x is 2 in the g function, so x is 2, what's the answer? It's negative 2. So we're going to replace this whole thing with negative 2. So f of negative 2, what does that equal? Again, negative 2 is the x value in the f function, so negative 2, and what's the answer? It is negative 3. So we use the inside answer to find the outside answer, and we'll say f of g of 2 is negative 3. Let's try another one. G of f of 1. Okay, so g of f of 1. Start on the inside function, f of 1. So when x is 1, what's f of 1? So when x is 1, the answer is 2. So now we want g of, and we're going to replace this with 2. Okay, so now in the g function, when x is 2, what's the answer? It's negative 2. So we say g of f of 1 is negative 2. It's kind of like a code. All right, let's go over one more. I need my eraser. Okay, so we have g of f of 4. So start with f of 4, the f function. When x is 4, what's the y value? The f of x value is negative 1. So g of negative 1. Look at the g function. When x is negative 1, what's the answer? It's 3. Negative 3. So we say g of f of 4 equals negative 3. And these are the answers. Okay, so that's composition of functions, using an answer from one to find the answer for another in a table. Sometimes they write the table like this. They'll just write it sideways, so you have coordinates. So let's try this. These input and output values. Start with f of 4, the inside function. All right, so when the x value is 4, what's the y value? Here it is. When the x value is 4, the y value is 0. So let's write g of 0 now. Replace this with 0. So in the g function, when the x value is 0, what's the y value? It's 6. So we're going to say g of f of 4 equals 6. Let's try the next one. G of 3. So start with g. When x is 3, what's the answer? It's 5. So now we want f of 5. Start the f function. When the x value is 5, what's the y value? It's 11. So we're going to say g of f of, sorry, I wrote that wrong. F of g of 3 equals, and it was 11. All right, let's try 3 in a row. Can we handle it? Let's see. So the next one, start with f of 7. Okay, so f of 7 is 3. So we have f of g of 3. So now find g of 3, and that's 5. So now find f of 5. F of 5 is 11 again. Okay, so we say f of g of f of 7 equals 11. Okay, let's look at compositions using equations. F of 2, okay, so that's review. F of 2 just means for every x, plug in a 2 in the f function. Okay, let's try this again. F of 2 means in the f function, plug in a 2 for the x. 4 times 2 minus 5. So we say f of 2, the answer when you plug in a 2 is 8 minus 5, which is 3. F of 2 is 3. Try this one though. F of g of 3 means start the g function. G of 3 equals negative 3 minus 3. G of 3 equals negative 6. So now we're going to replace this with the negative 6, and we're going to do f of negative 6. Look at the f function, plug in. 4 times negative 6 minus 5. Negative 24 minus 5. Negative 29. So f of negative 6 is negative 29. That should be a 6. Last one, g of f of 4. So I'm going to erase so I can use a different color. Let's use blue again. All right, start with f of 4 right here. F of 4, plug in a 4 for x. It's solved. So f of 4 equals 16 minus 5, which is 11. Okay, so now replace this f of 4 with an 11 and find g of 11 equals negative 3 minus 11. G of 11 equals negative 14. And there's your answer. We could say g of f of 4 equals negative 14. Okay, compositions of functions in a graph, the last thing. All right, so use one graph to find the answer, and then use that answer to find the next answer. So the first one is f of g of 0. Here's the g function. All right, g of 0 means when x is 0, what's the answer? So here's where x is 0. The answer, x is okay, so when x is 0, what's the y value? It's negative 1. So this is negative 1. So now we want to find f of negative 1. Excuse me. So when the x value is negative 1, what's the y value? And it also is negative 1. We went down negative 1. So we say f of g of 0 is negative 1. Sorry, I have a dry throat. Okay.
If your last name begins with letters O through Q, and you need to retake...
Start with f of 0. So when x is 0, what's the y value? It's 2. So now we have g of 2. Look in the g function. When x is 2, what's the y value? It's also 2. So g of f of 0 is 2. And the last one, let me pick a different color here. Let's do orange. G of f of negative 1. All right, f of negative 1. When x is negative 1, the answer is negative 1. G of negative 1, the answer is, oh, it's a decimal. So here it's about negative 1.4, I would say. So a composition is using the answer for the inside function to find the answer for the outside function.